Hello everyone and welcome to another video. In this video we are going to talk about coding conventions. Coding conventions are a really important part of any programming language. They are style guidelines for programming, and they typically cover naming and declaration rules for variables and functions, rules for the use of whitespace, indentation and comments, and programming practices and principles. In this video, I'm going to cover the most important JavaScript code conventions. If you stick to the rules stated in this video, people will perceive your work differently. Your team and your boss will appreciate you for writing clean code, but most importantly, you will be thankful to yourself. Coding conventions secure quality, improve code readability, and make code maintenance easier. They can be documented rules for team to follow or just be your individual coding practices. Robert C. Martin once written, "Clean code reads like well-written prose. Clean code never obscures the designer's intent, but rather is full of crisp abstractions and straightforward lines of control." This one sentence really embodies the importance of clean code. Let's see what those rules are in JavaScript and how we can implement them in our code. Let's delete this right here and let's start with our first rule. I'll write every rule like this in the comment and down below the example of the code. So let's start with magic numbers. So what are magic numbers? Imagine if you saw a code like this. So we have a loop which starts at 0 and then we have index is smaller than 86400 and then we have incrementation of the I. And we can do something right here. Do you have any idea what this number stands for? This is some random number right here, and maybe the person who wrote it had in mind what this is for, but when someone else is reading the code later, they have no idea what this number stands for. Magic numbers mean that we are assigning a number with no clear meaning. So it's better to replace it with a named constant. So we can do something like const seconds in a day, and we can make it equal to 86,400. This is much easier to read because then we can replace this and it becomes easy and understandable for everyone what we just did here. Later in this video, I'll tell you why did I use upper snake case for this. Okay, now we can move on to our second example, or second rule rather, and it is deep nesting. If your code contains many nested loops or conditional statements, then this should probably be extracted into a separate function. So let's say we have something like example array, and it is equal to an array of an array of an array, and it has one value. So this is just an example. You may come across code like this in your application, but let's just take this as an example. Let's say we want to retrieve this value inside of here. So to retrieve the central value right here, we could do something like example array that for each, and then we can pass in our first element, which is going to be this array. So we are going to loop through the first item of this array, and we can call it array 1, for example. Then we can do something like this and just call array 2. So this time we are getting inside of here. And for the third time, if we call array that for each, so like this, but now this needs to be array 1 and this needs to be array 2. Now here we have element and we can console.log this element, and we indeed do get this value right here. We can test this in the console. Right here, if we copy our code, we can get something like value right here. And that's okay. We indeed are doing what we are supposed to, retrieving this value right here. But as you can see in here, we have many nested values, one for each, second for each, third for each. And this code actually breaks more than one rule. It breaks 2 or 3 rules. First one is that we have deep nesting right here. The second one is that we have a lot of code repetition. So this also needs to be solved. To solve this specific example in a correct way, we can create a function that will loop through all the arrays and return a final value. So we can do something like const retrieve final value, and we can make that equal to an arrow function. And inside of here, we are going to have an if statement, and that if statement is going to check if our element is indeed an array. So we are going to pass an element to that function. Sometimes that element is going to be an equal of an array, like this or this, but sometimes that element will be equal to a string. So when it is indeed an array, we want to call this function again. So we're going to call retrieve final value, but this time it is going to have an index of 0. So we'll pass element and then 0. This will simply return the whole array, and then we are checking if it is an array, and if it is, we are passing the first index. So this is it. The second time we are passing this array, and this element 0 is going to be this. And the third time we are passing this array. Now this if statement is not going to work, and then we simply want to return element. Now we can remove this, actually pass our example array to our function call, copy all of this and get back to our console. We can refresh, remove the errors, and we can run it, and we indeed do get a value. So you can see that we do get the same thing, but this code is much cleaner and much easier to read. It is also less repetitive, and it is also reusable. Third rule may be a personal attack on some of you. It is stop writing comments. Although subjective, the use of comments in your code can be helpful, but could also be a sign that your code is failing to be self-explanatory. There is a great quote by Jeff Atwood that sums this up perfectly. While comments are neither inherently good or bad, they are frequently used as a crutch. You should always write your code as if comments didn't exist. This forces you to write your code in the simplest, plainest, most self-documenting way you can humanly come up with. So this really sums it nicely. Comments can be good, but your code should be self-documenting. It should speak for itself. If you think that sometimes you cannot write something that could be easily understandable without writing comments beside it, this video is exactly what is going to help you. So this is one rule. It is subjective a bit, but you can choose to follow it, and many will appreciate the cleanliness of your code without comments. So this is the third rule. We can also add code must speak for itself. Make it self-documenting. Now onto the fourth rule, which is avoid large functions. A function or even a class that is large in size suggests that it is doing more than it should. So let's create an example. Our example is going to be quite simple, and we are going to call it add, multiply, and subtract. It is going to be a function, an arrow function, that is going to accept three parameters, a, b, and c. The function needs to find addition, multiplication, and subtraction of these three numbers, and then it needs to return a string where each result is next to one another. So result 1, result 2, result 3, and we can even replace this with our pseudo variables, just like this. So this is what our function needs to do. Let's create that. We can first create an addition, so we'll call addition equal to a plus b plus c, simple as that. Then we can have multiplication, this will be equal, but we will just have times, and we can create subtraction, which is just going to be minus. Now when we have this set, we can return, and that return statement is going to return a template literal, and inside of here we are going to have addition, and we should rename this, so multiplication and subtraction, and we are simply going to return it side by side, one next to another, like this. Okay, this is all set. Now our function is going to return a string of first addition of these three numbers, multiplication of these three numbers, and subtraction of these three numbers. It is quite simple, but with this simple example, I just want to stress the fact that this function is doing more than it should. Imagine if all of these statements right here, so this one, is actually another function inside this function that is doing some logic that is extending over 20 or 30 lines right here. And then this function is also doing something that is extending even more. And we have such a long function doing so much stuff that we forget what we are doing. And as you can see at the end, we don't even know what we are returning. Now this is quite simple for this example, but imagine if we had a larger function. Now let's solve this in a way that will complement our clean code. So we can simply leave this as it is without these long lines. Let's remove that. It's better to create different functions to separate the logic. So let's first create a function that is going to add three numbers together. We are going to have A, B, and C, and we are simply going to return an addition of these three numbers, A plus B plus C. Since we are using ES6 arrow functions, we do not need to write curly braces. We can simply return the value like this. And we can also copy this. We can call it multiply and subtract. And now, simple as that, just if we exchange these values right here, now we simply have three different functions. We separated all the logic, and now we can use the result of this function anywhere we want in our application. Now this may seem oversimplifying things and separating too much logic. There is little logic here, but when you have a function that is doing a lot of stuff, simply separate it into another function and then call this inside one function and return what you should. Okay, so let's remove these comments right here and we can move on to our next rule. Okay, our next rule is code repetition. We mentioned something about code repetition in our second rule, but in here we are going to take in a look of how we can solve it. So code repetition. If you have to copy and paste a block of code, it's a sign that the repeated block may need to be extracted into its own function. Great example of this is our deep nesting example we had at the beginning. So we can simply copy that and paste it right here. In here, as we said, we have the same code repeated all over again. We have 3 times repeated the same for each statement. We have a lot of repeated code. It's much better to extract it to a different function and handle logic differently with less repetition. We already did that in our first example. So this is exactly it. We have an example array and we are not repeating any values anymore because we simply created a function that is solving the problem for us. Another great example of code repetition is retrieving data from parameters. So if we have something like const get user credentials, we make it equal to an arrow function, and in here we have a user. Now we can do something like const name is equal to user.name, and we can also do something like surname, maybe password, email, and we can extract many different things like this. But as you can see here, we are actually repeating the values quite a lot. So this is not a good practice. With ES6 object destructuring, we can simply do the following. We can extract all of this in one line. So we can type const, curly braces, and we can take anything we want from this user. So surname, password, email, and make it equal to user. This will actually extract all these values from the user object, and it is going to be the same thing that we had here, but with much less repeated code. So we can remove this and we can get back to our next example. Camel Case is a naming standard we use for identifier names, for example, variables and function. It states that the name needs to begin with a lowercase letter. So let's say we have some constant right here, and we need to begin with lowercase. So camel, for example, and then every first letter of the next word is uppercase. So for example, camel case. This is a camel case variable. Let's set it to an empty string. We can write some more examples. So const, this is a random camel case name. You can see that anything can be written in camel case. We can also write something like example function name. We also have, for example, get user credentials right here, also written in camel case, and add, multiply, subtract, retrieve final value. Everything we write in JavaScript should be a camel case. Another important rule regarding variable naming is use meaningful names. It is important to use meaningful names to our functions, methods, and variables, and they need to express their exact meaning. So let's say we are fetching posts from some user. we can type get user data. For example, we can call a method fetching post like that, and we can also call get user info, for example. But what info or data are we actually getting? Much better way to name it is get user posts. With this, we know that we're getting exactly that, posts, nothing more and nothing less. Also, when you're not sure, favor descriptive over concise. So this should be used only when you are not sure if the concise way is meaningful enough. You should always be as concise as possible. However, if you're having difficulty finding a 2 or 3 word description for your name, it is better to stay on the side of being descriptive. For example, if you need to find a user from a database, find user may be good, but find user by name or email is much more descriptive and much better. And for example, set user logged in true is much more descriptive also than just find user. But when there is a shorter version, use it. So use these long names only when you're not sure if the concise name is descriptive enough, but when you're sure, use a shorter version. While, for example, get user from database is really descriptive, there is a shorter version that means the same thing. The key question you should ask yourself is, does from database add any meaning to your program? The most likely answer is that it doesn't. We can assume that we are fetching the user from the database, and we can simply call our function get user. Simple as that. The next rule on the list is that we need to use consistent verbs per concept. Functions will usually create, read, update, or delete something. You could even be a bit more descriptive and say they create, get, set, add, remove, reset, and delete things. A function should be a verb or a verb phrase and must communicate its intent. We need to be consistent with our verbs. For fetching, we can always use get, for example, rather than get, retrieve, return, and 10,000 different names. For example, if you're getting some questions, we can simply call it get questions. If you're getting some users, you can call our function return users, and we can also call it retrieve users, but all of this isn't correct. All of these methods do exactly the same thing. If you call them, you get this thing. So you get questions, you get users, and in here you also get users. So it is much better that you use get for each single one of them. Or for example, if you're creating something, then use create for each one, or delete. Whichever verb you choose, make sure you stay consistent. So this can be much better if we use simply get for each of them. Much better. Another great thing for naming variables is that you need to make your booleans read well in an if-then statements. So, for example, if we are checking the characteristics of a car, which naming would you find more convenient? In here, we have only sedan, sold, green, airbag. Let's just create a variable named car so I can easily fill it out. And now, if we are checking if our car is indeed a sedan, we can simply call car sedan, or car that sold, car that green, or car that airbag. You get the point. What does car airbag really mean, or car green, or car sold? It is much better to do it like this. So car is sedan, and then we can read it like this: if our car is sedan, or if our car is sold, if our car is green, or if our car has airbag. This is much more descriptive and is much better to use this naming for our Boolean variables. This sounds more natural and make the program easier to decipher. Now, regarding the class names, this could also be a class since it has some properties right here. But let's move this to our next rule, which is use nouns for class names. Classes don't take things, they are things. More specifically, they are a blueprint for something. Creating a class is what makes something. If this is a bit weird to you, let's write it down and you'll see that it's actually quite simple. we can write something like class car is equal to, and then we can put it like this, capital C, because we write all our classes in Pascal case, opposed to Camel case for variables and functions. I'll show you that in the next rule. And now you can see that this is much better than class make car is equal to, and then do something. Because if you're making a new car, you wouldn't say make a new make car, you would say make a new car. This is much simpler, and simply use nouns for class names. The second rule is to use Pascal case for class names. So if you have a class, use Pascal case. Pascal case is simply like Camel case, like here, but only the first letter is also capitalized. So we can have Pascal case right here. If you use that, everyone who uses JavaScript knows that it is indeed a class. So we have something like class task. It is simply much more descriptive than class task, because then we don't know if this is an object or a class. That's it for this rule. And the next rule we briefly mentioned, it is capitalize constant values. We had it right at the beginning when we had seconds in a day. Remember that we've written our seconds in a day like this. Const seconds in a day is 86,400. In here, we are using yet another case. We are using snake uppercase. So snake case is simply words divided by this underscores, and uppercase because it is all uppercase. There are a few things we need to remember when it comes to this rule. A constant value is something that won't change. This convention has roots in C and is not always followed in JavaScript. Keep in mind that const and the term constant are not the same. The const declaration simply means that the value can be mutated through reassignment, but a true constant value is a primitive value that won't be changed later. Also, you may consider narrowing the definition to values that are not only primitive, but also inherently fixed, such as hours in a day, the value of pi, or the names of the days in the week. For example, hours in a day and user age is a primitive value that is not going to change in this case, and they should be capitalized. But for some other example, we have user, which is capitalized right here, but it shouldn't be, so these two examples are wrong. This user is equal to a found user, and found user can be anything. We are fetching it from somewhere, so this value is actually changing, and this user is not a constant. Today is equal to a new date, which is changing every single day. So although we set it as a constant right here, this is not a fixed constant, so it would be better if we called it like this, and the user like this. Okay, another rule, which is really important, is to avoid one-letter variable names. Assorted names cause more hassle than the keystrokes you save in the long run. A variable initialized in the global scope may end up being used 100 lines later. It becomes easy to forget what it was if it is only a single letter. So for example, let's say we have something like const q is equal to an arrow function, and we do something inside of here. We can also write it like this. What is q? Someone who reads the code later has no idea what q means. But if we do something like this, const query, this is much more meaningful. We know that it is some kind of query, and related to the code next to it, we could guess what this function does. Also, we can have another example. So let's say we have something like const d is equal to new date. This d is not descriptive, and when you use it later in code, you'll need to scroll up all the way where you initialized it, and you'll need to see what it is. But if you simply call it new date or something like that, you will always know that a new date is equal to a new date. So you need to be descriptive with your variables. There are only a few situations where you can use a single letter variable's names. You can limit them to a really small functions where you know exactly what this single letter means, and also it is okay to use them as an index in loops. You can indeed call this index. This is a really small and closed loop or function. This is okay. You know that this index is actually indexed inside of this small closed loop. So this is okay, but when you have bigger functions or any other variables, you simply use more descriptive names, and it is much easier not to get lost 100 lines later when you're looking for what this Q or this D or anything else means. So avoid one-letter variable names unless it's inside of a loop. Remember these conventions for your own future sanity. We went through it all. There are a huge benefits to following this rule in a long run. When others take your code you've written a few days or months or even years ago, they can immediately see what you were thinking when you're writing it, and they'll be able to continue adding some new features easily. Clean code makes it easier to start and continue coding. It is better for the individual as well as a team, and it is much easier to read. So always make sure to write code that is elegant and focused. We went through all of these rules. You need to avoid magic numbers, deep nesting. You can, if you want to, stop writing comments, avoid large functions, never be repeated. Code repetition is not good in programming. Also, your variable names need to be meaningful. They need to favor descriptive over concise to be consistent with your code names. So the person who reads through your whole source code of some application, when you use get for every single thing, for example, get question, get users, or anything else, they'll know that this method simply receives something and gets something, so always use get. But when you're creating something, you use create, so it is descriptive as that. I cannot stress enough the fact that booleans need to be written correctly. If this car is green, or if this car has airbags, it is really easy to understand that these values indeed are boolean values. Also, we mentioned that we need to use Camel Case for our class names, and that we need to make them nouns and not verbs, because they are something, they do not create something. Also, we learned that we need to capitalize constant values with snake uppercase. So if something is really set in stone, like seconds in a day, hours in a day, user age, or something like that, you can make it a constant written in snake uppercase. Also, one of the biggest rules is to avoid one-letter variable names. Be descriptive, be concise, but also make sure that everyone knows what this variable name indeed is. If you have some of the coding conventions for JavaScript that you personally use, make sure to let me know in the comments. That's it for this video. Thank you for watching and see you in the next one.